Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0102, indicates a low voltage condition in the mass airflow MAF sensor circuit. The MAF sensor plays a critical role in measuring the amount of air entering the engine, which is essential for optimizing fuel injection and overall engine performance. This code applies specifically to the Honda Fit models manufactured between 2015 and 2020 and is commonly tied to issues with the MAF sensor or related wiring. The MAF sensor is usually located in the intake duct, close to the air filter, allowing it to accurately gauge airflow before it enters the engine. Accurate functioning of this sensor is crucial, as the engine control unit, ECU, relies on its readings to adjust the air-fuel mixture for efficient combustion. A malfunctioning MAF sensor can lead to decreased engine performance, increased emissions, or even engine stalling, making it important for vehicle maintenance. The MAF sensor, crucial for engine operation, measures the volume and density of air entering the engine to help determine the correct fuel-to-air ratio. It is positioned in the intake duct, right after the air filter, to ensure it measures unimpeded airflow. When the vehicle's engine management system detects that the voltage in the MAF sensor circuit is lower than expected, it triggers DTC P0102. Such low voltage signals typically indicate either a wiring issue, fault in the MAF sensor itself, or a fault in the power supply to the sensor. Additionally, the Powertrain Control Module, PCM, uses the data provided by the MAF sensor to manage engine operations, emphasizing the sensor's critical role in vehicle functionality. Diagnosing this issue promptly is essential for maintaining optimal engine performance and fuel efficiency. Several potential causes may lead to the activation of DTC P0102. First and foremost, an open circuit in the MAF sensor wiring could disrupt the signal transmission to the PCM, resulting in low voltage readings. Also, poor or corroded connections at the MAF sensor or the intake air temperature IAT sensor may lead to unreliable signals. A faulty MAF sensor itself can be another significant reason where internal components may fail, causing incorrect voltage output. In some cases, the PCM might not be receiving the correct voltage due to issues within the integrated circuit that powers the sensor. It's crucial to thoroughly inspect all wiring and connections before concluding the MAF sensor itself is at fault. When DTC P0102 is triggered, drivers may experience several noticeable symptoms. Engine performance issues can arise, leading to poor acceleration, rough idling, or even stalling. Such symptoms occur as the engine management system is deprived of accurate information regarding airflow, causing inefficient fuel-air mixtures. Increased fuel consumption is another common issue, as the engine may compensate for perceived low air intake by injecting more fuel than necessary. Furthermore, the illuminated check engine light on the dashboard acts as a warning indicator, alerting the driver to the current issue. Each of these symptoms not only affects driving comfort, but could also contribute to long-term engine wear if left unresolved. Begin troubleshooting DTC P0102 by turning the vehicle's ignition to the on mode and allowing it to stabilize for 2 seconds. Using the Honda Diagnostic System, HDS, check the electrical parameters of the MAF sensor. Ensure that the voltage reading is less than 0.1 volts during this assessment. The current conditions should match this threshold for the system to be considered functioning properly. If the readings do align, you can confirm that the failure has been duplicated, allowing you to proceed to the next troubleshooting step. In contrast, if the necessary conditions are not met, it may indicate an intermittent failure. This would require a check for poor connections or loose terminals at the MAF and IAT sensors, as well as the PCM for any signs of wear or damage. For the second troubleshooting step, turn the vehicle's ignition off and disconnect the 5-pin connector from the MAF sensor/IAT sensor 1. With the connector removed, switch the ignition to on mode. This precaution allows you to check for power continuity in the circuit. Use a multimeter to measure the voltage between specific test points. The first point at pin 1 of the MAF/IAT connector, and the second point at body ground. If the measured voltage indicates the presence of battery voltage at this juncture, it confirms that the IG1 ACG/IG1 AFM wire is functioning correctly. In that case, proceed to the next step. However, if there is no voltage, this will indicate an open circuit within the wiring, necessitating repairs in the IG1 ACG IG1 AFM wire running between the MAF connector and the number C30 fuse. Next, ensure that the vehicle's ignition remains off and disconnect the MAF sensor IAT sensor 1 again. Assess the resistance across specific test points, specifically pin 3 of the MAF IAT connector and body ground. It is critically important to check that the resistance falls within the range of 190 to 210 kiloohms, k-ohms. Sufficient resistance in this range indicates that the possible failure area resides within these connections. If known, it ensures that the circuit is working properly, hence allowing you to progress to step 6. Conversely, if the reading falls outside this specified range, this would point towards issues that need to be further investigated in the wiring or connectors that comprise the VGP line. Moving to step 4 in the troubleshooting process, you will need to jump the SCS line using the HDS. This procedure safeguards against erroneous short signals. Disconnect the PCM connector B, which contains 51 pins, to allow for an isolated continuity check. Once both disconnections are made, check for continuity between test points. This entails measuring between pin 3 of the MAF sensor connector and body ground, while the vehicle is in the off position. If continuity exists, this confirms a short in the VGP wire running to the MAF sensor, requiring necessary repairs. If continuity does not exist, it indicates that the VGP wire is intact, allowing you to move on to assessing the next potential fault in the system. In this step, you'll again verify continuity, but this time, check between pin 3 of the MAF IAT connector and pin 32 of PCM connector B. Ensure that both connectors are still disconnected and the ignition is off. If continuity is confirmed at this juncture, it suggests that the VGP wire is functioning optimally. If this is the case, ensure that the PCM has updated software to ensure reliability. If required, substituting a known good PCM and re-evaluating the system will confirm whether the issue lies within the PCM. However, if you find that continuity is not present, this signals that there is an open issue in the VGP wire connecting the MAF sensor and PCM, necessitating repairs before moving to the next step. The final step in the troubleshooting process involves substituting a known good MAF IAT sensor into the system. Reconnect all previously disconnected connectors once the substitution has been made to ensure an accurate assessment can be performed. With everything back in place, turn the ignition to the on mode and clear any stored DTCs using the HDS. Following this, start the engine and allow it to reach an idle state. While maintaining an engine speed of around 2,000 RPM without any load on the engine, monitor the HDS display for any new pending or confirmed DTCs, specifically looking for DTC P0102. If the code continues to appear, it indicates that MAF IAT sensor is functioning correctly, and further exploration into the PCM may be warranted. If the code does not reappear after clearing it, and if the PCM was previously updated or substituted, the troubleshooting may be deemed complete. After completing the troubleshooting steps for DTC P0102, it's critical to conduct a final repair verification. This entails checking for any recurring symptoms associated with MAF sensing or voltage issues. Monitor engine performance during a test drive, paying special attention to any hesitation or stalling, which could indicate remaining faults. Utilize the HDS to confirm that DTC P0102 does not reappear after clearing the codes from the system, as this acts as a key indicator of successful issue resolution. Monitoring the engine's performance yields valuable insights into whether additional repairs are necessary or if everything is functioning as intended. This final verification is essential to ensure comprehensive resolution of the issue, thus promoting optimal vehicle operation. Preventive maintenance is crucial to avoid future occurrences of DTC P0102 and maintain optimal vehicle performance. Regular inspections of the MAF sensor should be performed, looking for signs of dirt or contamination that could affect sensor readings. Keeping electrical connections clean and secure is also vital, as poor connections can lead to intermittent failures and erroneous readings. It's advisable to visually inspect wiring for any signs of wear or damage that could disrupt sensor functionality. Implementing a schedule for these maintenance tasks creates a proactive approach to vehicle care, ensuring that problems are caught early before they escalate into larger, costlier issues. Adopting these preventive measures not only contributes to the longevity of the vehicle, but also helps in maintaining fuel efficiency and overall performance. In summary, DTC P0102 signals a low voltage issue in the MAF sensor circuit, indicating potential problems that can significantly affect vehicle performance. The steps for troubleshooting this error encompass verifying current conditions, checking wiring continuity, and testing the MAF sensor's functionality. Attention to detail during these steps is crucial, especially regarding wiring integrity and connector cleanliness, as many issues may stem from these elements. Preventive maintenance on the MAF sensor and its related components can greatly diminish the chances of this error recurring in the future. Consequently, diligent maintenance practices not only extend the life of vehicle components, but also ensure smoother and more economical driving experiences. Please like and subscribe to the channel. See you next time.